Hey guys, it's Alex from European Coffee Trip. We are in Oslo, Norway, and in this video we want to show you how coffee roasters are built from scratch. So follow me.
This is ROEST, this is us. This is where everything happens, basically.
Perfect. So can you show us around?
Yeah. We produce coffee roasters, and I think our high focus on smart, efficient solution combined with automation and technology. This is kind of what separates from the masses.
What's the correct pronunciation of the company?
Yeah, ROEST. ROEST would be the verb of roasting. Actually in the old Norwegian language, because we call it brenne, a fire. And in Norway we don't tend to roast that hard. When I was a student, and spent my Sundays kind of like trying to perfect my espresso shots and so on. And then I started doing some experiments home roasting. And at the same time, my brother was kind of doing the same, but he was a mechanical engineer student. So instead of buying the coffee roaster, he started building his own. This is Sverre's 1 kilo electric roaster. That's what was starting the whole thing. Then when he moved to Oslo, it kind of escalated by us showing the product to Tim Vendelbo and Morten Mennesgaard. They told us that what they really wanted was a sample roaster and explained their issues with it. Yeah, we were triggered by the idea of roasting just 100 grams and started developing it in our spare time, working weekends, evenings, nights, whenever we had the time. And then when we revisited Morten with our prototypes, we'd managed to outcup their coffee on the sample roasters they had. So this is a P1 all the way up to P6. So this is basically, I would say, 3 years of garage development. This is our first design. It was supposed to be electric, and since the community preferred gas, we were like, okay, let's go gas. And this was an extremely important model for us. With this model, we secured the funding we needed to get out of the garage. So this is kind of like the breakthrough. I quit my job, started working full-time. We got these awards and recognition and a lot of interest. We also hired our first software developers internally, not just using developers. So I think fall of 2019, that was like when we became a company, not just two strange guys in a small office. But then again, the gas didn't really work. So one night Sverre was thinking, but maybe we should go back and test out electricity, because in the meantime we have done some more research, and we already on the second day outperformed the gas-powered unit. So then we decided, okay, let's go full electric, and luckily we didn't need to change. So that's kind of like the story of our development.
ROEST has its office and production facility in the suburbs of Oslo.
This is ROEST, this is us. This is where everything happens, basically.
Perfect. So can you show us around?
Yeah.
The team consists of 15 people who are spread across product development, production, sales and marketing.
Everybody at least have had to make a roaster so they understand their work. This is basically where we do all the assembly of the roasters. As you can see, we have quite a lot of parts which we have to build up. It's more than 200 parts in the sample roaster, and we do all the assembly here.
So there are over 250 parts to build the roaster. Let's look at how they put all the pieces together. We followed the production manager Scott James in assembling the one roaster from scratch. He starts by building the framework that gives the core of the roaster its structure and rigidity. Then he puts on the electronics, PCB and sensors.
This is the first stage complete and the box is empty.
In the next stage, he attaches the drum and the rotating pedals. The pedals need to be precisely aligned. The roasting chamber is silicone sealed, so it keeps all the heat inside. From there, he puts the proximity sensor on, so when you pull the bean stopper up, all coffee beans go in and the roasting starts. Before moving on, the first crack detection card is placed just next to the drum. Then he adds the heater fan unit and the cable sensor for drum lights, and he gives the heating element the power. At this stage, the machine is ready for the first mechanical testing in the lab.
Testing profile.
Now he adds the chef separator unit and front screen. At the final stage he has side panels, top plate with the encoder, and the roaster is ready for the high temperature testing in the lab.
So we test all the roasters quite significantly. First we do a heat test, and then we also roast the coffees. Each roaster is on the test bench for 2 to 3 hours, where we figure out kind of like if there's any problems, or we can also adjust the sensitivity of the first crack card, for example. When the testing is done, we do the final assembly in here, where we then add the side panels, find the handles, and do the last settings on the roaster. We pack it up and ask FedEx to come pick it up. Where we separate ourselves, our advantage is when it comes to efficiency and also the first crack detection. In terms of efficiency, it's because we've designed a roaster that cools the coffee on the outside, which is normal in a shop roaster, but it is designed for heavy-duty use. It is designed for 60 to 100 batches per day for a long time. The whole idea about first crack detection, I mean, in the beginning, well, our roaster worked, so you put in the coffee, you roast a predefined profile, but then you mark first crack when you kind of hear pop, pop, pop. And then you have a preset development time afterwards in either in seconds or a percentage. And we wanted to take away this. So first crack detection basically just picks up the first cracks and marks it depending on the beans. So it will end the roast based on the kind of like the condition of the coffee, not just based on time or temperature. Another thing is that we needed to make a roaster that if it failed, it could be fixed easily. So you can actually open up the hood and yeah, the engine is there, it's for you to pick it apart. Our goal is that the sample roaster should live for a long time. But then P2000 is of course the main new product.
We wanted to make something we think is fun, and we wanted to have a 1 kilo roaster. So that's kind of how we started. We just I want to create a roaster that when I go to a coffee shop and they could roast their coffee on a machine that I have developed. We have learned a lot from the sample roaster, and we want to see if we can take all those learnings and put it into a new product.
Looking at P2000, there are a few things we've never seen in the coffee roaster before. First, this machine is packed with custom-built temperature sensors.
We are measuring a lot of temperatures inside here, but the most important are temperature of the inlet air, and then the temperature of the bean mass, and then the temperature of the drum. When we have those three, we can make an extremely consistent roast. All of our temperature sensors are custom made. They're very, very fast to respond, much faster than a traditional probe.
P2000 has a camera that can capture images and help you with roasting.
So many more things we could do with the camera. So we can obviously do color detection, measure the bean size. We can see how the beans are expanding, especially through first crack. We can also see the different variation between the bean size. So customer orders a Kenyan AA, put all the information in, and then the machine gives feedback back, no, this is AB.
With all the technologies and data they will be gathering from the community of roasters, the P2000 will be able to use machine learning to make roasting a little less demanding and mistake-proof.
So if a customer has a brand new coffee, they haven't roasted this coffee before, they can basically put the information in and ask the machine, what would a good starting point be? And based on what all of our customers are doing, the machine can actually recommend you a profile that you can start, and that will probably be quite close to what you want, so you can tweak it from there and take it into your style. That's one of the cool things that we'll be able to do with all the information we're gathering from this machine. Our end goal is that people should be able to roast better coffee. As I see it from the producer's side, the coffee has been harvested. Basically, the only thing you can do is deteriorate the quality. And we want to make sure, at least in the roasting process, we keep the quality up.
It was fascinating to see how ROEST grew from a garage to an award-winning product used by specialty coffee roasters and experts around the globe. Still, implementing new ideas and working on new products.
It's extremely rewarding to know that we managed to do so, and we have a great team with us. Yeah, together we are kind of trying to shape the future of roasting, and I think we are on a good path.